Okay, so question question 4, the question reads, um, solve the system using Cramer's rule. So the system, we have x plus 2y minus z equals to 3. Okay, so that's the z that we have equals to 3. 2x minus y plus 2z equals to 7. We have 3x plus y plus 2z equals to 4. Okay, now, so how do you go about this, as in solving using Cramer's rule? So let's consider the coefficients that we have. Okay, so the coefficients of x there, we have 1, 2, and 3. The coefficient of y, we have 2, -1, and 1. The coefficient of z, we have -1, 2, and 2. Okay, so these are the coefficients of x's that we have. Then this is equals to the coefficients of the answers that we have there. We have 3, 7, and 4. Okay, so these are the answers that we have. Okay, so this is what we have from there. Okay, so I'll just get this and put it aside somewhere. Okay, even here. Okay, so from there now, so we have this is x, y, z. Okay, and these are our answers that we have there. Okay, so from there now, what follows? Okay, so if you look at what we have here, the first thing that we need to do for us to solve Cramer's rule, we need to know the determinants, because this is the formula for Cramer's rule. Cramer's rule we go with, let me just use a different pen here. We have x. If I want to solve for x, it will be x is equals to dx over what? Over d, which is the determinant of x over the determinant in general, comma, you have, if you want to solve for y, it will be y equals to dy over d, okay, which is the determinant of y over the determinant there for the whole thing. Then if you want to solve z, to be z equals to dz over what? Over d. So the determinant of z. So this is what we are supposed to find. So we need to find the determinant of, we need to find first the determinant for the whole thing, the whole system, and the determinant of x, the determinant of y, and the determinant of z. So now how do you find the determinant for the whole system there? Okay, so the first thing that we need to consider the determinant for the whole thing is, let's take a look at what we have there. So the first thing that we need to go with, x there for us to determine for us to come up with the determinant for the whole system. So we need to consider the coefficients of x there. We need to consider as well as the coefficient of y, and as well as the coefficient of what? The coefficient of z. That is why this is what we are going to use for us to do what? To determine the determinant of the whole system, which is d. Okay, so I'll remove this part because this part is not needed for us. So this is the part that I'm going to remove. Okay, so this part, it has to go. Okay, then we say that this has to be equal to what? Has to be equal to the determinant, which is d. Okay, let me just use a different. Okay, so from there now, let's do the calculations. How do you find the determinant? So we cross out this. Okay, so this is equals to d. So we say, okay, if we take this and that out, we are going to remain with this here, which is a 2 by 2 matrix. Okay, so with what we are going to remain with here is what we are going to use. So remember, we are following this. We have plus, minus, plus, and the negative. This is what we are following. This is our guide. Okay, so from there now, the midpoint that we have there is 1 for this and that, where the intersection part there that we have 1, and 1 has to be what? In positive, followed by negative, positive, negative. It goes like that. So we're going to have d, okay, equals to, so we have 1. Okay, so now let's find the determinant. The determinant, we said that we find by multiplying the product in the major diagonal minus the product in what? In the minor diagonal. So this is what we are going to do. So it will be 2 times -1. We're going to have 2 times -1, that is -2. So -2 minus 1 times that is 1 times negative. What is 1 times 2? That is 2. Okay, okay, we go with the minus there. So minus. We move to the next one. So I'll use a green. So if we cancel this and what is on the middle there, we are going to remain with this part here and that part there. So it will be 2 times 2, that is 4. 2 times 2, so we are going to have, I'll use the same. So we're going to have the midpoint there, we have 2. Okay, open parenthesis. 2 times 2, that is 4, minus 3 times 2, that is 6. Okay, then we go with what? The last part there. So it will be this. If we cancel out that and that, the midpoint there that we have is -1. So it will be plus what? Plus negative. So we have -1. So here we have a plus. So we include the plus that we have. Plus, open parenthesis, -1, close. Okay. Then we open another parenthesis there. So we have -1. This is our midpoint. So if we cancel this and that, we're going to remain with it. This is what we are going to remain with. Okay. So what is 1 times -2? What is 1 times 2? I mean, that is 2 minus 3 times negative. What is 3 times -1? We're going to have minus 3. Okay. We cross. Okay. Then from there now, let's find what? Let's find our answer. So it will be our D, which is the determinant for the system, is equal, we have 1. Okay. What is -2 minus 2? That is -4. We close the parenthesis. Minus 2, open parenthesis. What is 4 minus 6? That's -2. Positive times negative, we have a negative there. What is negative? What is 2 minus -3? Negative times negative, that is positive. So it will be 2 plus 3, that is 5. Okay, so we're going to have minus 1, in parenthesis, 5 there. Okay, so from there, our determinant is equals to 1 times -4, that is -4. Okay, -2 times -2 multiplied by -2, that is going to have +4 here, because negative times negative, that is a positive. -1 times 5, that is -5. Okay, so our final determinant here, it will be D, equals to what is -4 plus 4, that is 0, minus 5, that is -5. So -5 becomes our determinant for what? For the whole system. Okay, so now that we know the determinant for the whole system, let's move to what? To the determinant for x, the dx. Let's go to dx. Okay, so now how do you find dx? I'll erase this part. I'll erase this part here for the determinant in general. Then I can write now the values that we need to consider for what? For our determinant of x. Okay, so this has to go. This has to go. Okay, so even that. Okay, so now let's go to x. Now, how do you find the determinant of x as in dx? How do you find dx? So you say dx here is equals to, let's pick out the coefficients that we are going to use for our dx. The coefficient of dx that we are going to pick, so we go with the determinant, the answers there for the last part. We go with our 3, 7, and 4. Okay, 3, 7, and 4. This is the format that you're supposed to, for you to find x, you need to start from here. Okay, so 3, 7, and 4. Then we go to what? To the determinant of y, because x, it is not supposed to be there. We go to the determinant of y. We have 2, -1, and what? And 1. Then from there, we pick the determinant of what? Of z, because we say that x is not supposed to be there. Okay, so we pick the determinant of z, which is -1, 2, and 2. So this is what we are going to use for us to come up with what? With dx. Okay, so now let's move. So from there, dx is equals to, so we do the same process. So if you cancel out this and that, okay, so our intersection part there is 3. So we have 3 here. Okay, open parenthesis. So what is 2 times -1? That is -2, minus 1 times 2, that is 2. Okay, we close. Okay, so minus, using a different ink here. If you cancel that, and what is on the middle, 2 is our midpoint there. So it will be 2, which is our midpoint. Okay, open parenthesis. Okay, so we are going to have what? If you cancel, if you follow the y there, I mean the yellow canceling there, we're going to remain with 2 and 7. So 2 times 7, that is 14. So we're going to have 14 here minus 4 times 2, that is 8. Okay, so from there plus, let's move with the last part now there. So I'm using green, cancel out that, and you cancel out that. We find that -1 there is our intersection. So it will be -1. So in the parenthesis there, okay, open another parenthesis. Then we're going to remain with what? We have 2 and 7. That is 2 times 7, that is 14. 2 times 7, that is 14. Okay, 4 times 2, that is 8. So we have 2 times, oh sorry. If you cancel out if you cancel out the green part has been cancelled. So it is this part here and that part. So we are remaining with this. Yeah, okay, we are remaining with that. So it will be 1 times 7, that is 7. So here it has to be 7, not what I have. Okay, so it has to be 7. So we 1 times 7, that is 7. Okay, minus 4 times -1, that is -4, minus 4. Okay, close the parenthesis and introduce the bracket there. So from there now, we are going to move dx equals to, we have 3 open parenthesis, -2 minus 2, that's -4. We close the parenthesis, minus 2, open another parenthesis. What is 14 minus 8? Okay, 14 minus 8, we have 6. So 6 here, we close the parenthesis. Positive times negative, that's negative, -1. Okay, open the parenthesis there. Negative times -4, that is, we're going to have a +4. So it will be, what is 7 minus -4? So it will be 7 plus 4. So that is 11. Okay, so we have 11 there. Okay, so it will be dx equals to 3 times -4, that is -12, minus 2 times 6, that is 12, minus what? 11. Okay, minus 11. Oh, minus 11. Yes, because of this negative there. Okay, so from there, we are going to say dx is equals to, what is negative? What is -12? -12 minus 12, that is -24. -24 minus 11, that is -35. So this one becomes for what? For our x. Okay, we go to what? To dy. So the same process, the same procedure, we go to dy. Okay, so dy, let me just try to get this and put it down there. Okay, so this is our dx. That is our dx here. So it can come down here, dx. Okay, then we erase this part. We erase this part. Okay, so this part. Okay, let's go to dy. Let's go to our dy. So dy, what coordinates are we going to get? I mean, what coefficients are we going to get for our y? Okay, so we leave out y. This y goes out. Okay, so we go with what? With the coefficients of x. With the when we leave out y, this one has to be left out. Y. We concentrate with the coefficient of z first. We go with the coefficient of z, then the coefficient of the answers that we have there, as well as we come to what? We come to our x part. Okay, so our x part, we have 1, 2, and 3. Since we have left out what? Our y. So we're going to move with the coefficient of x there, which is 1, 2, and 3. Then we go our y coefficients have been left out. Why? It's because we are not this is what we're supposed to find there. Then from there we move to what? To the answers there that we have 3, 7, 4. Then we come back to what? To the z, which is -1, 2, and 2. Okay, we close. So these are the coefficients that we are going to use. And from there, remember this, we have plus, minus, plus, minus. This is what we're following. So from there, we say dy, okay, dy equals to, I use red here. We cancel this and that. Okay, so 1, that's our midpoint there. I mean our intersection, we have 1 open parenthesis. So 2 times 7, that is 14, minus 4 times 2, that is 8. Okay, we close, minus, we go to the next part. Okay, that goes out and that. So the intersection there is 3. So we are using 3. Okay, so we go with 3. So we have 3 open parenthesis. 2 times 2, that is 4, minus 3 times 2, that is 6. Okay, plus, okay, we go with the last one, cancel out that, and we find that -1 there is what? -1 is our midpoint, our intersection part, -1. Okay, open parenthesis. So if you cancel the yellow part, we're going to have 4 times 2, 4 times 2, which is 8. So we're going to have 4 times 2, that is 8, minus 3 times 7, that is 21. Okay, then from there we say dy equals to 1 open parenthesis. What is 14 minus 8? What is 14 minus 8? We have 6. Okay, 14 minus 8, that is 6, minus, okay, close parenthesis, minus 3, open another one. What is 4 minus 6? That is -2. We close the parenthesis. Positive times negative, that is -1. Here you open a parenthesis. What is 8 minus 21? 21 minus 8, okay, 8 minus 21, that is -13, minus 13 here. Okay, we close the parenthesis. From there, we move our dy equals to 1 times 6, that is 6, minus, oh, -3 times -2, that is positive what? 6. -1 times -13, that is positive what? 13. Okay, so it will be dy is equals to, what is 6 plus 6? That is 12 plus what? Plus 13. So our dy is equals to what? So dy is equals to what? What is 12 plus 13? We have 25. Okay, so our dy is equals to 25. dy equals to 25, 25 here. Okay, so let's take this down there again as well. Our dy is equals to 25. This is our dy here. Okay, 25. Okay, so let's move now to dz and d. We find the values now of z and d, the rest. So we cancel this. Okay, so we cancel out this, what we have there, this goes. Okay, so let's go to dz. This is the last part that we have to deal with. So dz equals to, okay, so what values are we going to to use? So we leave out what? We leave out the z part. So the z part, all the coefficients of the z has to be left out. Then we go with that all the parts of the z part, all the parts of the coefficients of z has to be left out, and we move with so we have the coefficient of 1 there. I mean the coefficient of x, which is 1, 2, and 3. From the coefficient of x, we go to the coefficient of what? The coefficient of y, which is 2, -1, and 1. Okay, then from there we go to 3, 7, and 4. The z part has been left out. So these are the coefficients that we're going to use to find what? Dz. So we say, okay, dz is equals to, so if you cancel out this and that, we find that the midpoint there is what? Our intersection part is 1. So we move with 1 open parenthesis. What is 4 times -1? That is -4, minus 1 times 7, that is 7. Okay, we close the parenthesis. Plus, minus, plus, minus. So we go to the negative, we have minus here. Okay, so let's cancel out that and on the middle there. Okay, so we are going, the middle, the intersection part there is 2. Okay, open parenthesis. So if you cancel the green part, we're going to have 4 and 2. What is 4 times 2? That is 8, minus. What is 3 times 7? That is 21. Okay, we close the parenthesis. Plus, okay, let's cancel the last part. That and that. We find that 3 there is what? 3 there is our intersection. Okay, so we move with what? With 3. So plus 3 open parenthesis. Okay, if we cancel if we follow the yellow part, we're going to remain with 1 and 2. So what is 1 times 2? That is 2 minus 3 times -1, that is -3. Okay, we close that. Okay, so now from what we have, our dz is equals to 1 open parenthesis. What is -4 minus 7? -4 minus 7, that is -11. Okay, minus 2 open parenthesis. What is 8 times? What is 8 minus 21? That is 8 minus 21. 21 minus, what is 8 minus 21 of? That is -13. Okay, close the parenthesis, plus 3 open another parenthesis. What is 2 minus -3? That is 5. Okay, so to be that is 5, yes, because negative negative positive, 2 plus 3, that is 5. Okay, then from there we move dz is equals to, what is 1 times -11? That is -11. -2 times -13, that is positive what? 26. Plus what is 3 times 5? That is 15. Okay, so it will be dz is equals to, what is -11? What is -11 plus 26? Okay, plus 15. Oh, it has to be 15, this one, not 5, because 3 times 5, that is 15. Okay, plus 15, so we're going to have 30. Okay, so these are the values that we have. So dz, we have dz, the determinant for the whole system, which is -5, and the determinant for x and determinant of y. So from there, now let's find the values of x, y, and z. Okay, so this is how we solve using the what? Using the Cramer's rule. Okay, so from there, let's cancel out what we have there so that we can find the values of now x, y, and what? And z. So now, how do you find the values of x, y, and z? So easy and so simple. So from there, we move with what? Dx. So let's start with our dx. This is the formula that we have. Okay, so this formula that we have, let me just copy it here so that, okay, so this formula that we have is the one that we're going to use. So say, okay, x is equals to, what is our dx? We go back down there. Dx we calculated what? To be 35 there, -35. So okay, so our dx is -35 over our what is our determinant for the whole system? That is -5. So determinant for the whole system is -5. Okay, so we're going to have x is equals to, what is -5 into -35? That is 7. So 7 becomes our answer for x. Okay, we move to y. So y equals to dy over dx. What is our dy over d? What is our dy? It is 25. Okay, 25. Remember, this is the formula that we're following here for y. So it will be dy there is 25. Okay, over what is determinant? It is -5. Okay, so y is equals to, what is -5 into 25? That is -5. Okay, so this one becomes our value of what? Our value of y. So let's go to z. Okay, so z equals to dz. What is our dz? Our dz, that is 30. Here is our dz here. That is 30. Okay, so we have 30 over what is our determinant there? The determinant for the whole system is -5. So z equals to, what is -5 into 30? That is -6. Okay, so this becomes our final answers for what? For the Cramer's rule, for this that system given a 3 by 3. Okay, so this is how you find the values of x, y, and z, and you get your what? 15 marks. Okay, so without wasting much of the time, let's go to question B. Okay, so how do you solve question B? How do you solve question B? Okay, so let me just erase this part so that we can have enough space for us to do what? To solve the whole system there. Okay, so we move to question B. So question B said, the question reads, given matrix C, C is equals to 3, 7, 5, and 2. Okay, So this is what we have there. Given matrix C equals to 3, 7, 5, and 2, determine the determinant. So the determinant is easy. That is what we are just from doing question A. So the determinant of C is equals to, remember the product, we subtract the product in the major diagonal minus the product in what? In the minor diagonal. So the product is multiplication. What is 2 times 3? That is 6, minus 7 times 5, that is 35. Okay, so the determinant there of C is equals to, what is 6 minus 35? 6 minus 35, we have negative 29. So negative 29 becomes what? Our determinant of C. Okay, then B2, this is 1. Okay, then we go to B2. B2, determine if it is invertible. Now, how do you know that a matrix is invertible? A matrix is invertible if the given determinant, if the given determinant is not equal to what? 0. So if the let me just write this down. I'm using a blue pen. So a matrix, okay, a matrix is invertible. A matrix is invertible, okay, is invertible if, okay, if the determinant, let me say here we've been given the determinant of C, so I'll use the same C. If the determinant of C is not equal to what? Is not equal to 0. Okay, so if the determinant of C is not equal to 0, and here we've seen that the determinant of C is negative 29, and negative 29 is not equal to 0. Therefore, since, okay, let me just say, since the determinant of C is not equal to 0, therefore matrix C is what? Is invertible. Therefore, matrix C is invertible. Okay, invertible. Simple and straightforward. So if a matrix is invertible if the determinant of a given matrix is not equal to 0. Okay, that is when a matrix is invertible. But if the determinant of a given system is equal to 0, then that matrix is not what? Is not invertible. Okay, so now here they're saying that a matrix is invertible if the determinant of C is not equal to 0. And what we have here, the determinant of C is negative what? 29. So this negative 29 is what? Is invertible. Okay, I mean this matrix that we've been given here is what? Is invertible. So let's go to question B3. If so, determine the inverse. So now how do you find the inverse? So we have our determinant there. We have our determinant in that is what we have. Okay, so with what we have, question 3, I'll just write it here, question 3. Okay, so how do you find the inverse? So to be the inverse of the matrix given, the inverse of the determinant given, we swap the what? We swap from the major diagonal. Okay, we swap the numbers that we've been given there from the major diagonal. Okay, so the products in we swap the numbers that we've been given from the major diagonal. The 2 comes on the 3 and 3 comes on the 2. So we put 2 where there's 3 and 3 where there's 2. Then from there, then these are from the minor, they just gain signs. If it's negative, it becomes positive. If it's positive, becomes negative. So it would be negative 5 and negative 7. Okay, then what is our determinant? Our determinant we calculated to be negative what? 29. And the inverse of negative 29, it is 1 over what? Negative 29. Then we multiply the whole system with 2, negative 7 here, negative 5, and 3. Okay, so if you want, you can leave it here. This one becomes your final answer. Or if you want, you can do the multiplication, whereby you are going to have something like, let me just erase this part. You're going to have your answer, your final answer, which looks like this. Okay, so we're going to have negative 1 over 29 times 2. We're going to have negative 2 over 29. Negative 1 over 29 times negative 5, we're going to have positive 5 over what? Over 29. Negative 1 over 29 times negative 7, we're going to have 7 over what? Over 29. Negative 1 over 29 multiplied by 3, we're going to have 3 over what? Over 29, which is negative. Okay, so this is the answer that you're going to have as what? As your final answer if you multiply that with the determinant there, which is inverse, the inverse of that. So this one will become your final answer. So this is question what? This is question 4. So let's go to question 5 quickly. Okay, question 5. Question 5, solve it quickly so that we can finish the whole paper in what? We can finish the whole paper on time. Yeah, you can follow me on YouTube. You just search Peter's Academy there with the same profile picture, which is Facebook. That's what you're going to find there. Then you can be able to subscribe and be able to follow for more videos. Okay, so we move to question 5. Question 5 here. Okay, so question 5, the question reads, solve by completing the square what? Solve by completing the square. Okay, so now how do you solve this by completing the square? So let me just write down what we've been given. X squared, I have to start from, okay, here. So I have x squared minus 6x plus 5. So we solve this equals to 0. We solve this by completing the square. Okay, so now completing the square, we solve this by completing the square. So now how do you solve this by completing the square? So we go direct. Since the coefficient of x here is 1, so we're not supposed to temper anything with this, but we concentrate on what? On the sum there. So let's find the half of that. So we're going to have x minus, what is the half of 6? That is 3. Okay, so that same half we square here minus the same half, it has to be squared. Okay, plus what? Plus 5 equals to 0. Okay, so from there we have x minus 3 squared. Here now, what is 3 squared? 3 squared is 9. Remember, we're not squaring with the negative. No, it's just the 3 squared. So minus 3 squared there is what? Is 9. Okay. It's not negative 3 squared, no, but we are just squaring this part. That's what we are squaring. Okay, so plus 5 equals to what? Equals to 0. So we have x minus 3 squared. Okay, what is negative 9 plus 5? That is negative 4 equals to 0. From there, we collect like terms x minus 3 squared equals to 4, because this one has to go the other side and it's negative when it crosses an equal sign, becomes a positive. So from there we move. What do we do from here? We introduce the square root. Why? It's because for us to cancel the square. So the square root there and the square root. So we cancel the square and the square root goes. So it will be x minus 3 equals to, what is the square root of 4? That is 2. So it will be plus or minus 2. Okay, so from there we can find now the value of what? The value of x. So x minus 3, we start with positive equals to 2, or x minus 3 equals to negative 2. Okay, so let me just erase this part down here. Let me just erase this part. Okay, so what we have, x, what is x? So we collect like terms, so to be x equals to 2 plus 3. Okay, so if this 3 goes the other side, it becomes positive, or x equals to negative 2 plus 3. Okay, so we're going to have x equals to, what is 2 plus 3? That is 5, or x equals to, what is negative 2 plus 3? That is 1. So this becomes the values of what? The values of x, and this is how we solve using completing the square. From there, let's move to question question what? Question B. Question B, the question reads, a particle's displacement is given by st equals to 2t squared plus ht plus 1. Okay, let me just write this down there. Question 5. Question 5b. So we erased part so that at least we can have a space to do our calculations from. So this is engineering mathematics 1. Engineering mathematics 1, and more videos are coming for the same. Then from there we are going to move to engineering mathematics 2, engineering science, electronics. We solve all the papers there. Okay, so question 5b, a particle's displacement is given by, so we have st equals to negative 2t squared, st equals to negative 2t squared, st, okay, equals to negative 2t squared plus 8t plus 8t. Okay, so what do we have? Plus 8t plus 1 plus 1. Okay, plus 8t plus 1. Then what does the question say? Determine the time it takes to reach maximum displacement. Okay, the time it takes to reach the maximum displacement. Now, how do you determine the time it takes to reach the maximum displacement? So that's where we are. So it's so easy to follow the what? To follow the guidelines for you to be able to determine the time it takes to reach what? The maximum displacement. So if you look at what we have here, this is the quadratic equation. This is our A here. We have B and C. Okay, so the maximum displacement. So remember, when you find a question which says sketch this, I think I've seen a question which talks about the sketching. Yeah, question 4 here. This question here. Sketch the graph ST labeling the vertex and the intersects. So now the vertex and the intersect. So how do you sketch this? So now the sketching part, it comes in. We have the S. Now, if we say that if T is equals to 0, whereby the S of T there is 0. Okay, if T is equals to 0, we say that T is equals to 0. We substitute throughout by T there. We're going to find that the displacement there is equals to 1. Okay, the displacement there is going to be equal to 1. Then from there, now how do you know the graph that you're going to come up with? We look at what? The coefficient of A there. The coefficient of A. Now, if you look at the coefficient of A, if A is greater than 0, if A is greater than 0, then we are going to have what? We are going to have a minimum point. This is the graph that we're going to have. But if A is less than 0, we're going to have what? A maximum point. Okay, we're going to have a maximum point. So the graph is going to look like that. Okay, so now look at what we have here. A is -2, and -2 is what? -2 is less than 0. So we're going to have a maximum point. And how do you find the maximum point? Easy. So x equals to -b over 2a. And this is the formula that we are going to use to find the what? The maximum point. The question here, it says, determine the time it takes to reach the maximum displacement. Okay, determine the time it takes to reach the maximum displacement. Okay, so what we have here, we are going to do the substitution part. So to be x, here the x, it is t, so it will be t. Okay, the t that we have, that is our x. So it will be t is equals to t is equals to negative, what is our b there? B is 8, so it will be -8 over 2. Okay, so -8 over 2. What is our a? Our a is -2. Okay, so -8 over 2, -2 there. Okay, so t equals to 8 over -4. Okay, then t there is equals, that is -4 into 8, that is -2. -4 into 8 is, oh sorry, I have made a mistake. Okay, so I've forgotten about the negative there. So negative a, okay, so we're going to have, this is negative. Okay, we can't find a time which has, finding time which is negative. How? Okay, so now we have -4 into -8, that is +2. We have +2. Okay, so the +2, that is what we have there. Okay, so here it was -b. Our b there is 8, so it will be -8 over 2. What is our 8? Is -2, so it will be -8 over 2 times -2, that's -4. So -4 into -8, that is +2. And this is the time that we have to reach the what? The maximum point. I mean the maximum displacement, -2. Then we move to what? To question to calculate the maximum displacement. So how do you calculate the maximum displacement? We know the maximum time. Okay, we know the maximum time for us to do what? Calculate the maximum displacement. We know the maximum time. I mean, we know the maximum the time it takes to reach the maximum displacement. We know that. Now calculate the maximum displacement. Just substitute. Okay, so -2. We have, this is the equation. So this is our equation. So where there is x into this equation, keep on substituting what? With 2, because 2 is the one which takes to reach, 2 seconds to reach the maximum displacement. Okay, so we are going to move with our, so s open bracket and 2 equals to, what is, we have -2, time there is 2 squared plus 8, open parenthesis 2, okay, plus 1. So our maximum displacement, what is that? Is 4. 2 squared, it is 4. -2 times 4, that is -8, plus 8 times 2, that is 16, plus 1. Okay, so -8 plus 16, that is 8, plus 1, that is 9, equals to 9. So for us, calculate the maximum displacement. And the maximum displacement there that we had, it was 9, and we don't know which units these are using. Okay, so it was 9 what? 9 units. Okay, so that's what we have. It was 9 what? 9 units. Okay, so we go to find the time it takes, find the time, find the time it returns to its initial position. Okay, returning now of the initial position, how does it return to its initial position? So initial position, okay, let me just write, let me erase this part. So the initial position, oops, okay, so the initial position, for it to erase to initial position, you know that t is equals to what? T is equals to 0. So that is the initial position. So if t is equals to 0, if t is equals to 0, as in our initial position, we say that, okay, so let's try to substitute where there is t into the equation. We keep on substituting with what? With 0. So we're going to have our st, our time there is 0, initial position, equals to -2 open 0 squared plus 8 open 0 plus 1. Okay, so you find that the displacement that we're going to have there is equals to what? Is equals to 1, as in our displacement that we have. Now if we have that displacement of 1 that we have there, let's be able to solve it. If we say that our displacement is equals to 1 that we know now, let's try to find the time. I mean, let's try to find now the displacement when the time returns to its initial position. Okay, so we know that time at 0 seconds, because this is the initial time that is going to retain. So time at 0 seconds, the displacement is equals to 1. Now let's try to find the time that is going to take it all back to what? Its initial position state there. So what we are going to do is we substitute, we try to equate the equation that we've been given equal to what? Equal to 1. Okay, so the equation has to be equated to what? To 1. So we say, okay, -2 t squared equals to, oh, -2 t squared plus 8 t plus 1 equals to 1. We calculated this to be 1 equals to 1. We have two t's there. So let's try to find the time. We're going to know that we're going to find out that the other time is going to be 0. The other time has to give us something. Okay. So from there we have -2t squared plus 8t is equals to 1. This one goes the other side. We collect like terms, minus 1. Okay, so it will be -2t squared plus 8t is equals to 0. So the 0 that we have there, I'll erase this part, is equals to 0. So let's find the time there now. There is the time that is returning to its initial position there. So from there, what can we do from here? Okay, we have something which is common. Let's find out what is common. -2t, open parenthesis, remain with t plus what? If you factor out, no, not plus, but minus. Okay, it has to be t minus, because we have a negative outside the parenthesis. So negative becomes a positive. So it has to be negative here. So it will be t minus 2 into 8, that is 4. Okay. Okay, so -2t times -4, we're going to have positive. Okay, that was what we're going to have there. So equals to what? Equals to 0. So it will be -2t equals to 0, or t minus 4 equals to 0. So here we divide throughout by -2, also here by -2, we cancel. So t equals to 0, which is what we calculated at first, or t equals to, we collect like terms, equals to 4. Okay, so therefore, since t, we said that t, let me just use a different ink here. We say that t is equals to 0, as in this one, since t is equals to 0, and this is our starting time. Okay, this is our starting time. Now the particle returns to its initial position after what? After 4 seconds. After 4 seconds, that's when the particle returns to it what? To its initial position. T is equals to 0, as in the starting time. Now find the time it returns to its initial position. It is 4 seconds. So this is how we calculate this. Okay, let's move to question 4. Question 4. The question reads, sketch the graph, st labeling the vertex and the intercepts. So the sketching part, I'm going to use the details which are just written here. Okay, so this is where my conclusion was from. Okay, so now I'll use, let me, okay, so, okay, let me just try to erase the, oh, what have I done? Okay, let me just erase this part. I'm erasing everything there. The coordinates, okay. So we're going to have this. It's just the sketching part. Okay, that's what we have. So we have 0 here. So remember I said that if a is less than 0, if a is less than 0, then we're going to have what? We're going to have a maximum point, and a is less than 0 because a is -2. If you look at what we have here, our a is -2. That is our a here is -2, and -2 is less than 0. So we're going to have a maximum point. So this is the graph that we are going to have. And we say that if t is equals to 0, if t is equals to 0, s is equals to 1. We substituted 0 throughout. We substituted 0 throughout this, and we found that s is equals to what? S is equals to 1. So now let's plot this. This is our x and this is our y. Okay, so we say that this is our y. This is where the 1 is. So this is 1. So I'm putting a mark here. Okay. From there now, if we have this, let's try to factorize the equation. Let's try to factorize the equation. This one here, is it factorizable, or we just go direct using what's this? That formula, the Almighty formula. Okay, is it factorizable, this equation? We have -2, so that we can find the what? The vertex, -2x. I mean the intercept, -2x squared plus 8t plus 1. Is it factorizable? Let's try to factorize it. That is -2 times, we're going to have -2 here and 8. Do you have any? No, it's not factorizable because we don't have any numbers that we can multiply to get -2 and add to get 8. We don't have, so this is not factorizable. So we don't have those numbers. The numbers that we can multiply, the products that the two numbers that we can multiply to get -2, and those same numbers, if we add them, we get 8. It's not possible. We don't have those numbers. So it's not factorizable. Therefore, we are going to use the Almighty formula. So the Almighty formula we are using t, so it will be t. Okay, I'll use, let me just come here. I'll try to take up this space. Okay, let me take up this space so that I can have enough space to do my solvings. Okay. Okay, so let's solve this. Okay. So from there we have let me take this up there. So this is what we have. Okay, so from there with this we are using t. So we are using t, so to be t equals to -b plus or minus the root b squared minus 4ac over what? Over 2a. So I'm using this to find what? The intercepts. So to be t equals to, what is our b? This is our a, b, and c. So our b is 8. So to be -8 plus or minus the root. What is b? It is 8 squared minus 4 open parenthesis. What is our a? Is -2. What is our c? Is 1. Over everything has to be divided by what? By 2 and the -2. Okay, so t equals to -8. Okay, t equals to -8 plus or minus. Okay, now the root 8 squared, that is 64. 8 squared, it is 64. So we have 64. Now what is -4 open parenthesis, -2 and 1? Okay, so we're going to have 8. So we're going to have 8. So now what is 64 plus 8? 64 plus 8, or what you can do, you can just punch everything on what? On the calculator. So we're going to have 72 here over what? Over -4. Okay, so t equals to -8 plus, what is the square root, plus or minus, what is the square root of 72? That is 8.46. What are 8.49? So we're going to have 8.49 divided by what? By negative 4. Okay. So t equals to negative 8 plus, we start with the plus first, plus 8.49 over what? Over negative 4. So t equals to, what is negative 8? What is negative 8 plus 8 point what? 49? That is 0.49. You divided by what? Negative 4. We're going to have negative 0.1225. Okay, as in the first one. Or let me erase this part. Okay, so or okay, so let me just have this space, or t equals to negative 8 negative 8 minus, since we've done with the positive part, there would be minus 8.49 divided by what? By negative 4. Okay, so it will be now t equals to what is negative 8? Negative 8 minus 8 point what? 49. Okay, we're going to have negative 16.49 divided by what? By negative 4. We're going to have 4.1225. We're going to have 4.1225. So these ones becomes our answers for what? For t. So these are the two intercept answers. So 0 negative 0.11, negative 0.225, and 4.1225. So these are the values of t. Now if we get these values of t, what we have here, and be able to substitute there, we're going to find that our s, this s here is equals to 0. So now it will be 0 comma what? 0 comma so this is the value of t, which is x, so to be comma 0. Even this one, it will be what? Comma 0. Okay, so we have negative 0.1225 comma 0. So we go the value of x. So the negative 0. This is the negative part, negative 0 point as in x. Okay, so this is the y part, this is the x part. So negative 0 point, we're going to have, this is the negative part here, negative 0 point something. Okay, that's the negative part that we have. Then comma 0. Okay, comma 0. Then this one we have what? 4.225 as in our x, 4.225 comma 0 as in y. So 4, we're going to, this is our 4. So this is 4.225, and this is negative 0. Oh, the 4, it is in positive form. Sorry. This is our x. This is these are the values of, this is in negative form. Okay, the x is not in positive, so 4 point here, 4 point 4 point what? 4.1225, 4.1225, 1,225. That's just the sketching. Then this one, it is negative 0.1225. Okay, so those are what we have. So this one is not there. Let me just erase this part. This is not there. Okay, we have a straight line. So from there now, let's find the turning point. Okay, what is the turning point for this? The turning point, this is how we find the turning point. So the first thing is we have x, which is t. So t equals to negative b over what? Over 2a. So it will be t equals, what is our negative b? What is our b here? Our b, it was 8. Okay, so we had negative, I think we found this negative 8, okay, over 2. What is our 8? Negative 2. So we had something like negative 8 over negative 4. So equals to what? 4 into 8, that is 2. Okay, so we have 2 as in our value of t, and when we substitute t I mean 2 throughout this, we're going to find 9. Yeah, we had 2,9. 2,9. So the 2,9 is the one that we're going to plot. So this is t here, and this is our displacement part. So 2,9, so I'll say t 2,9. So this is our 2 here, this is our 2, okay, and 9, I'll take it to be here. Okay, so that is the point that we're going to have here. So 2,9, this is the point that we have there. So you find that, you see that this is how the graph is going to go. Okay, so it was starting from this point, going up there, meeting that there. Okay, so this is the maximum point that we have. So the maximum point there, we have 2, what? 2,9, and these are the 2 points where the graph does what? Where the graph has been cut into 2, the intersection part. Okay, so we have this point here and this point. This is the intersection part. So this becomes the graph of what? This becomes your graph for this. Labeling the what? Sketch the graph ST, labeling the vertex. So the vertex, this is the vertex part. This is the vertex that we have. Okay, the vertex, and the intercept, we have 4 and negative that. So the intercept, that's what we have. Okay, so that is the intercept. We have negative what? Negative 0.1225 comma 0, and what? 4.1225 comma 0. Okay, so this is the intercept part that we have, and we end here. So this is how we solve question 4 5, I mean Roman numeral 4.